Okay, section 2.3, biconditionals and definitions. So today we're going to talk about biconditional statements. We talked about conditional statements yesterday. They were if-then statements. Biconditional means two, well, bi means two, so biconditional will be two if-then statements put together. A biconditional statement is an if and only if statement. So to start us off, we're actually going to talk just about a regular conditional statement. So here's a conditional statement. It says if two angles have equal measures, then the angles are congruent. That is true. If they have equal measures, then they're congruent. The converse of then, converse again, switches the if and then parts. So if I wrote the converse would be if two angles are congruent, then they have equal measures. Because again, remember, a converse takes that first and second part and switches them around. The first one was if they had equal measures, then the angles are congruent. And so the converse switches that. If two angles are congruent, then they have equal measures. That is also true. If two angles are congruent, then they have equal measures. Now, when that happens, when you have an original statement and the converse, when they're both true, you can make a biconditional statement. And a biconditional statement says, hey, it works both ways, no matter which way you put it. So this one as a biconditional statement would be two angles are congruent if and only if they have equal measure. All right, so a biconditional statement is just saying, hey, it works both ways. If two angles are congruent, then they have equal measures. Or the other way, if two angles have equal measures, then they're congruent. So that's what the if and only if thing means. It means that it's true both directions. It's a biconditional statement. So biconditional. A biconditional statement is an if and only if statement. It can happen when both a conditional statement and its converse are true. If you want to add that, that's fine. All right, an example, let's say, there you go. A figure is a triangle. We talked about this one yesterday. If and only if it has three sides. Right? A triangle has three sides. If you got a shape that has three sides, it is a triangle, so it works in both directions. All right. Good definitions, I've got that here. That's kind of a silly one to have for a word, but a good definition can be rewritten as a biconditional statement, because a good definition will have a definition that's only true for that thing you're trying to define. So good definitions can be rewritten as biconditional, which again are if and only if statements. All right, you can, we're going to talk about those good definitions a little bit later, but first let's focus on those biconditionals. So let's try this one out. Each conditional statement below is true. Write its converse, and if the converse is also true, then combine the statements as a biconditional. All right, so statement number one, if an animal is a spider, then it has 8 legs. That's true. Spiders have 8 legs. Eight legs. Let's talk about the converse. The converse would be if an animal has 8 legs, then it is a spider. Now, this first one was true. If an animal is a spider, then it has 8 legs. This converse, however, that's false. So we can't rewrite it as a biconditional statement. It's false because there are some counterexamples. All right. Let's try statement 2. If an angle is acute, then it has a measure that is less than 90 degrees. The converse would be if an angle is less than 90 degrees, then it is acute. The original is true. This other one is also true. Those are both true. If that happens, we can rewrite the statement as an if and only if statement, as a biconditional. So let's do that. My biconditional. Okay. You would just say an angle is, let's say acute first, is acute if and only if the angle is less than 90 degrees. Biconditionals, you take both those if and the then parts and you rewrite them with an if and an only if in the middle. It means it's true either way. If you've got an acute angle, it's less than 90. Other way around, if you have an angle that's less than 90, it's acute. That's what a biconditional statement is. All right, let's try doing it the other way around. Let's break a biconditional statement up into the two statements that are true about it. So I've got an example 1, biconditional statement 1. If it's daytime in Minnesota, it is daytime in Minnesota if and only if it's nighttime in Australia. So this is two things that go both ways. It's day in Minnesota if it's night in Australia, which is true, and the other way around. If it's night in Australia, that must mean it's daytime in Minnesota. So rewriting that as two conditional statements would just be if it is day, you guys okay if I just say day instead of day? Well, I can say daytime. If it is daytime in Minnesota, then it is nighttime in Australia, right? That's one of the statements. But again, biconditionals are two statements put together. The other one would be if it is nighttime in Australia, then it is daytime in Minnesota. You got the first part, daytime in Minnesota, nighttime in Australia, and you could just rewrite that as two conditional statements in different orders, both the original and its converse. So a biconditional combines both of those into a single statement. Let's try one more just to make sure we got it right. Two angles are supplementary if and only if they sum to 180. One statement I could say, if two angles are supplementary, then they sum to 180 degrees. Or I could have done it the other way around. If two angles sum to 180 degrees, then they are supplementary. Biconditional statements. Two statements put together in one. All right. Very last thing for today is talking about good definitions. So definition is a good definition if it can be written as a true biconditional statement, if and only if the statement, because a good definition will be very specific to that one thing. So for an example, for this multiple choice, which of the following is a good definition? A is not a good definition. A fish is an animal that swims. Sure, it's true, a fish is an animal that swims, but there's lots of other animals that swim, right? That's not a good definition for a fish. Giraffes are animals with very long necks. Again, that's true, but they're not the only animals with very long necks. Not a good definition. Rectangles have 4 corners. Again, true, but rectangles aren't the only thing with 4 corners. Not a good definition. A penny is worth 1 cent. That is a good definition, because a penny is the only coin that is worth 1 cent. So this one could be rewritten as a biconditional statement. I could say a coin is a penny if and only if it is worth 1 cent. That is true. A coin is a penny if and only if it's worth 1 cent. Any coins that are worth 1 cent, they're pennies. Any pennies, they're worth 1 cent, right? I couldn't have done that with like this rectangle one. I couldn't say a shape is a rectangle if and only if it has 4 corners, because that's not true. There are other shapes with 4 corners that aren't rectangles. All right. In this notes, I had an extension. Pick one of the above that is not a good definition and explain why not. I already did that verbally as I went through here, and I crossed things off and I explained why they weren't good definitions. I would challenge you to try looking back at one of those and remembering and seeing if you can explain in your own words why it's not a good definition. If not, maybe reverse the video, go back to the part where I was crossing those out and see if you can see how I explained why those weren't good definitions. Your assignment for today is page 101 in assignment section 2.3. There's only 1, 2, 3, 4, 5, 6, 7, 8 problems. Those 8 problems. See you later.